So here is a GAMS program. This is the correction of the assignment concerning the first computable general equilibrium model I asked you to do. So I started the program with comments between instructions $on_text and $of_text. So this is a model that I designed with Yvan de Creux. And here you've got the declarations of parameters. Of course, there is nothing difficult here because it's all the parameters that are necessary for the program. So you've got technical parameters like alpha and A0, which is the total productivity of factors, but you also have parameters concerning exogenous variables like supply of labor and supply of capital, and you have initial value for the variables of the model. Well, you have only two data to enter for this model from the social accounting matrix. It's the supply of labor and the supply of capital. And then you must normalize prices. So I remind you that normalizations, it's a change of unit for each good that is in the model. So in this model, you have the output, price P, and you have two primary factors, capital price R and labor price W. So you change the unit for a quantity. The new unit is the quantity of each of these goods that you've got for $1 or euro, depending on the monetary unit that you have adopted. Then the calibration, it's an important part of the program because you must respect a specific order. Why? Because here, the first three equations, you've got something which comes from the data that you have entered within the program, because you have a supply of labor and supply of capital, and in the model you have two equations which are KD is equal to KS and LD is equal to LS. So if you have entered data for LS and KS, you can calibrate KD 0 and LD 0. And then you have also entered a value for R0 and W0. So if you look at the model, you can calibrate INC0 because INC in the model is equal to WLS plus R times KS. So you can calibrate INC0. You follow the model. And then if you have a value for INC0, you can calibrate C0 because in the model you have the equation P times C is equal to INC. So you can calibrate C0. It is INC0 over P0. Then you can calibrate Y0 is equal to C0 because in the model you have the equation Y is equal to C. It's the market equilibrium for goods. And then you can calibrate alpha because you have in the model the demand for capital, which is R times KD is equal to alpha times P times Y. So you can calibrate alpha. Be sure that you have a parenthesis at the denominator, because if not, you can have one term of these products which is at the numerator instead of being at the denominator. Then you can calibrate the total productivity of factors, and you can calibrate Léon 0, which is the initial value for the Léon variable. So in the model, the Léon is positioned on the labor market equilibrium. So you can write this. Léon 0 is equal to LD0 minus LS. But of course, you could also have enter a value of 0 for Léon 0. Then you declare variables. Then you initialize each variable. So it means that you give a value at this stage of the program. So each variable has a value which is its initial value. So you understand why I use the same annotation for a variable and a parameter, but of course the parameter is ended with 0, and y0 is a parameter, y is a variable. This is why I have to specify a suffix which is .l, which means the current value of variable y is equal to y0. And then you've got declarations of equation. Don't forget a comment. You see that the annotations of equations, it's eq underscore y, so it's a specific variable. It is the name of the variable which is determined by this equation. Of course, it can be misleading because in fact, when you will solve the model, all variables will be determined simultaneously. But you have to think about one equations is for the determinations of a specific variable. So you see that you have the program with Léon, which is on the labor market equilibrium. I define the model which I call macro, and it consists in all equations which are in the file. And I also define the numeraire because you have in fact one variable, you have one more variable as compared to the number of equation, so you have to fix one price, and so the numeraire is the price of labor, the initial price of labor. Then you ask for a solve without any shock, so it's just to check that the model has been well calibrated. So here this is to ask for a solve, and we will check that the initial infeasibility is 0. Then I implement the shock. This is an augmentation of the labor supply by 10%. What I'm doing here is that this is a buffer parameter, because in fact if you ask for displays of the labor supply at the end of the program, you will have the final value of the labor supply. You will not have the initial value. So a buffer parameter, this is called ls underscore for the name of the variable or the name of the parameter followed by underscore. This is just to stock the initial value of this parameter, and so I write ls underscore is equal to ls, so I give the value, the initial value of ls in ls underscore, and then I change the value of ls and I ask for a solve. So it means that one equations will not be respected because the labor supply has changed, and so GAMS will search for new values of all endogenous variables in order for each equations to be strictly respected. And once it will have solved the model, it will calculate parameters, which is the growth rates of GDP, the growth rate of output price, and the growth rate of capital remuneration. Of course, you can ask for other calculation. Just here, I will check that I will ask for a display of the value of the parameters. I also want to check that the final value of the Léon is equal to 0. So what I'm doing is that I type Léon.L, so I ask for a display of the current value of the variable Léon. This is to check that the final value of Léon is equal to 0 in order to check that the Walras law is respected. So I press run. Here I am in the process window. So the first shock, you see that the initial infeasibility is 0. So it means that the model was well calibrated. Then you've got a second solve with an initial infeasibility of 1400, and in 9 iteration, GAMS has found a solution, that is to say value for the 8 variables, such that all equations of the model are respected. In fact, the infeasibility is very close to 0. So I can look at the results of. So if you double click on the left part of the .lst, you may have, for example, the statistics of the model. So you check here that there are 8 free variables and 8 independent equations. Okay, so here you see that initially you have 8 equations but 9 variables, but 1 variables is not free. So you have a square system because you have 8 free variables and 8 independent equations. The results, well, you have growth rates of GDP which is close to 7%, a growth rate of output price of 2.9%. So it means that with an increase of labor supply, you have economic growth, but with economic growth you have inflation, some inflation, and you have an increase in the remunerations of capital by 10%. So it's normal because in fact each unit of capital is more productive because there are more workers. Okay, so on the contrary, if you would have an increase in the stock of capital with the same quantity of labor, it would mean that each worker has at its disposal more units of capital, more machines, more trucks, more tools. So it means that each worker would be more productive. So it's normal. In fact, if the quantity of the other factor augments, it means that the productivity and the remuneration of a factor augments. And you have Leon.L, which is equal to 0 or very close to 0. If I look at here the equation, so if you double click here on equation, you see that you do not have any infeasibility because here you have a value for the left hand side, and you do not have infeasibility because if you add infeasibility, you would have 4 stars and a level of infeasibility on each equation. Okay, so on all equations of the model, you do not have any infeasibility. This is the first solve, so it's normal. If you look at the second solve, so here I double click on equation, and so here you've got an infeasibility because here the labor supplies has changed. So the formations of income, you have an infeasibility, which is here mentioned, an infeasibility of 700. So you have 4 star, you have an infeasibility, and then on the equilibrium on labor market, you have also an infeasibility because the labor supplies has augmented by 10%. So you have an infeasibility. So you have, I hope, understood how to design this very simple model, computable general equilibrium model.